Let us discuss about gate problems of chemical reaction engineering in the year 2021. So in the question 10 it is given ethylene is adsorbed on the vacant sites of a transition metal according to the following mechanism. C2H4 plus 2 vacant sites gives rise to C2H4B and V. Okay. If that is the case, NT is representing the total sites available on the transition metals, on the catalyst. NV is the vacant sites available, and 2 or the number of sites adsorbed by the ethylene molecule. If that is the case, out of these 4 options, one is valid. So you can see that every 1 mole of ethylene takes up the 2 vacant sites. Okay, this is the information that is provided. If I do the site balance, that means NT is representing the total sites. So imagine there is active sites that are present. NT are the total sites, okay, on the catalyst, on which every 1 mole of the C2H4 adsorbs on the 2 sites. Rest everything is a vacant site. So according to this, that means total sites, that means 2 sites occupied, because every 1 mole is taking 2 vacant sites. That means 2 times the sites and C2H4, that sites occupied by the ethylene molecule, plus remaining is NB. Okay, total sites is nothing but occupied sites plus vacant sites. So out of this information, the correct one is this particular information, that is option B is the correct answer. Okay, the question number 24 states there is a reactions when A gives rise to B, B gives rise to C, and C gives rise to A. All 3 reactions are the reversible reactions. The rate constant values of all these reactions is also provided, and K1 is provided, K minus 1 is provided, K2 is provided, K minus 2 is provided. But K3 is provided, which is 10, K minus 3 is not provided. So we have to find out the value of K3 in the given mechanism and the given rate constant values. So let us take up the first 2 reactions. A gives rise to B. So if it's a reversible reaction, net rate of formation, whatever you could be think about, net rate of is nothing but forward reaction minus backward reaction. So K1 into Ca minus K minus 1 into Cb equal to 0, because at equilibrium it's a reversible reaction. At equilibrium the net rate of reactions will stop. If net rate of reactions will stop, you are supposed to do forward reactions minus backward reaction should be equal to 0. From this information, Ca by Cb is equal to K minus 1 by K1. Similarly, from the second reaction, the Rb equal to 0. Therefore, forward reaction is K2Cb minus K2Cc equal to 0. So similarly, from the third reactions, you can suppose to calculate K3 into Ca minus K minus, for here you can see the forward reaction is represented as K minus 3 and backward represented as a K3. Okay, forward reaction is K minus 3 into Ca, backward reaction is minus K3 into Cc equal to 0. From this information, 3 relationship will emerge, and 1 and 2 and 3. If you multiply 1, 2 and 3 equations, Ca by Cb into Cb by Cc into Cc by Ca. Okay, K minus by K1 into K minus 2 by K2 and K minus 3 by K3. These are the information. So all the informations are provided except K minus 3, because Ca cancels out, Cb cancels out, Cc cancels out, and that means on the left hand side you get the value of 1. From this you can able to calculate K minus 3 by knowing given values of K1, K2, K minus 1, K minus 2 and K3. You get K3 is equal to 0.5 into 1 by second. Thank you. Let us move to the next problem. In question number 49, it is given the following isothermal autocatalytic reaction happens. A plus B gives rise to B to B. That means one of the product is getting again reacted. Okay, because the product is also B, the reactant, one of the reactant is also B. So because more product is forming than the getting reacted. If one of the product is getting reacted, so this comes under autocatalytic reactions. For a given autocatalytic reaction, it is given rate of reaction is 0.1 Ca into Cb. Okay, it is the reaction, particular autocatalytic reaction, this happens in a CSTR. If that is the case, given the pure A at 1 mole per liter, that means initial concentration is given, the Ca0 is 1 mole per liter, and reaction in this reactor is 90%. If that is the case, what is the space time of this particular reactor? Okay, the only step you need to remember in the autocatalytic reactions is the concentration step. Okay, because you can see A plus B gives rise to B plus B. Okay, this comes in autocatalytic reactions. A is forming B. Okay, only at a time, at any point of time in the reactor, A and B are present. A is getting reacted, B is getting formed. Again B is getting reacted, again B is getting formed with A. Okay, that means the total moles of A plus B, that means the total concentration of A and B in the reactor will remain the same, because A will form B, again B is getting reacted. So at any point of time in the reactor, this condition valid. The total concentration is CTO, that means if you talk about the initial concentration, Ca0 plus Cb0. After a certain point of time, after the reaction also, which is called total concentration, is nothing but Ca plus Cb. At any time, this concentration will not change, because A will become B, again B will reacted to form again B. So this is the typical case of autocatalytic reactions. So total moles remain the same before and after the reaction. Before the reaction, if you take of CT0, and after certain reaction you take it as a CT, both are always matching. Okay, that means Ca0 plus Cb0 is equal to Ca plus Cb. You need to remember this particular method of solving, especially for the autocatalytic reactions. So rest everything is very simple. So volume of the reactor in a CSTR is Fa0 into x by minus Ra, which is a design equation of a CSTR. From this, Fa0 equal to Ca0 into mu0, Fa0 molar flow rate, this is the concentration, this is volumetric flow rate. From this information, Fa0 is nothing but Ca0 into nu0 into Xa by minus Ra. Therefore, tau is nothing but volume by volumetric flow rate. So, volume by volumetric flow rate is nothing but Ca0 into x by minus Ra. Minus Ra is already provided, which is 0.1 times Ca into Cb. So, let us substitute the different values of Ca and Cb here. I know what is the conversion? Ca0 initial concentration minus final concentration of A divided by initial concentration, which is nothing but the conversion of A. That means in place of x, you can able to substitute this particular expression. Okay, Ca is nothing but Ca0 into 1 minus x. You can see this is a kind of autocatalytic reactions, and it is not provided whether it's a liquid phase or a gas phase. So let us assume the gas phase. For the gas phase, the concentration of A is Ca0 into 1 minus x by 1 plus epsilon x. Epsilon, I mean, you can calculate Ya0 into delta. What is Ya0? Initial concentration of A multiplied by delta. What is delta? Nothing but final moles, product moles minus reactant moles. Product moles are 2, reactant moles are also 2. So 2 minus 2 equal to 0. So therefore epsilon equal to 0. Finally, in place of Ca, you can substitute Ca0 into 1 minus x. In place of Cb, what you are going to substitute? Here from this equation, Cb equal to Ca0 plus Cb0 minus Ca. What is the initial concentration of B before the reaction? Nothing, because only pure A is fed to the reactor. In such cases, initial concentration of B equal to 0, therefore Cb equal to Ca0 minus Ca. So in place of Cb0, substitute Ca0 minus Ca and follow space time is nothing but volume by volumetric flow rate. So numerator Ca0 minus Ca and denominator Ca0 minus Ca both got cancels out. Finally, space time is equal to 1 by 0.1 times Ca. Ca equal to Ca0 into 1 minus Xa. I know the conversion they are expecting in this reactor is around 90%. That means X information is given. So substitute the information of X, and finally you are supposed to calculate the space time for this reactor to conduct this autocatalytic reaction for the conversion of 90% is 100 seconds. And thank you. Let us move to the next problem. In short, it is given the reactant A decomposes to form B and C. It's because it is said that enzyme, in presence of enzyme, that is biochemical reactions. Okay, the kinetic expression for this biochemical reaction which happened this continuous stirred tank reactor, minus R equal to 0.01 Ca by 0.05 plus Ca. This is a rate of reaction of this particular enzymatic reaction which happened in a CSTR is provided. What you are supposed to calculate, if the initial concentration of A is 0.02 mole per liter, time taken to achieve 50% conversion of A. The information given here, I mean, at the first half of the story is CSTR, but they are asking us to calculate the time taken. This time taken has nothing to do with the CSTR. That means the second information is, that means just to, the confuse you, they have provided the information, the rate information, they got it from the CSTR. From this rate information, you are supposed to calculate using the batch reactor. That means what is the time taken to reduce the concentration. That means 0.02 mole per liter to half of the concentration. For a 50% conversion of A in the batch reactor, how much of time that is needed? Because you cannot calculate time in the CSTR, because reaction happens at instantaneously in the CSTR. That means they are indirectly giving the information that using a batch reactor, tell me the time for the 50% conversion. So minus Rs, because it's a Michael-Menten equation, it's a standard equation, minus R equal to Vmax into S by Km plus X. If you compare these two, the Vmax information is provided, Km information is provided. So let us take Vmax as a K1, Km as a K2. K1, K2 are 0.01 and 0.05. So let us use the rate information in this batch reactor to find out the time for the 50% conversion. That means the time for the 50% conversion, you can use this equation, time equal to 0 to x Ca naught by minus Ra into dx. This is in terms of conversion, this is in terms of the concentration. Time needed for reaching the concentration, that means the final concentration from initial concentration, that is Ca is the final concentration, Ca0 initial concentration. The design equation for the batch reactor is T equal to integral Ca to Ca0 dCa by minus Ra. Minus Ra information is provided, which is K1 Ca by K2 plus Ca. So you simply substitute in place of Ra and try to integrate. If I can able to integrate, okay, the first term is the ln term, second one is the normal term. So finally time is equal to K2 by K1 into ln Ca0 by Ca plus Ca0 minus Ca by K1. I know initial concentration, which is 0.2. What is the final concentration? Because it is asked to find out the for the conversion of 50%. But that means the time at a 50% conversion, what is the final concentration of A in the reactor? Ca equal to Ca naught into 1 minus x. Ca naught is equal to 0.02. Conversion is 50%. 1 minus 0.5, it is 0.01. Final concentration is 0.01. Initial concentration is 0.02. So simply you substitute the values of, in this particular K1, K2 is already provided 0.01 and 0.05. So if you substitute, final time for the 50% conversion is 4.465 minutes. This is the final number, that is the time for the 50% conversion in this batch reactor. And let us move to the next problem. Okay, this is question number 51. It is said that the following homogeneous irreversible reaction involving ideal gases. That means this is a gas phase reaction. If that is the case, the reaction is A gives rise to B plus C. The rate of reaction of A is 0.5 times Ca. Is carried out in a plug flow reactor at isothermal and isobaric conditions. So the feed stream consisting of pure A entering at a velocity of 2 meter per second. Remember, the initial velocity is given. To achieve 50% conversion of A, the required length of the reactor is dash meter. That means what is the length of the reactor for the 50% conversion with a velocity of with the initial velocity of reactants is 2 meter per second. And you can see if it's a plug flow reactor, the cross sectional, let us assume the cross sectional area of the reactor is A, the length of the reactor is L. Because it's a gas phase reaction, the concentration of A is Ca naught into 1 minus x by 1 plus epsilon x. Because it's gas phase reactions, and how to calculate the epsilon? Ya naught into delta. What is Ya naught? Initial concentration, mole fraction of A. It is said that pure A is fed to the reactor. If pure A is fed to the reactor, the mole fraction of A is 1. What is delta? Delta is nothing but product stoichiometry minus reaction stoichiometry coefficients. That means in the product 2 moles, in the reactant is 1 mole. That is 2 minus 1. This is 1. Epsilon, if you multiply Ya naught into delta, the value of the epsilon will be equal to 1. So it is a simple what is the space time? Through this space time information, we can calculate the length. So space time is nothing but volume by volumetric flow rate is nothing but Ca naught into 0 to x dx by minus Ra. This is a standard design equation for a plug flow reactor. And volume by volumetric flow rate. What is volume? Area into length. What is volumetric flow rate? Velocity into area. So in place of volume, substitute A into L. Volumetric flow rate, substitute velocity into area. Area got cancels out. Tau is nothing but L by V. Therefore, L by V is nothing but Ca naught into integral 0 to x dx by minus Ra. From this, if you integrate this particular expression, you get length of this particular reactor. So through the mathematics, we have found out the length is nothing but velocity into minus 2 into ln of 1 minus x minus x. The conversion, it is said that for 50% conversion, we are supposed to calculate the length of the reactor. So if you substitute in place of x is 0.5, you get length of the reactor is 3.545 meter. Let us, I will show you that how I reached to that equation. You can see this is the equation. L by V bar equal to Ca naught into dx by minus Ra. So what is minus Ra? Minus Ra is nothing but K Ca0 into 1 minus x by 1 plus epsilon x. Simply you substitute, and K is constant, get out of the integral. So you are supposed to calculate 1 plus epsilon x by 1 minus x into dx. Epsilon is also equal to 1, we have calculated. So simply, and integral 0 to x 1 plus x by 1 minus x. So 1 plus x by 1 minus x is nothing but 2 by 1 minus x minus 1. If you do that, you will again get the same expression. So let us integrate. Integral 0 to x 2 by 1 minus x into dx minus integral 0 to x into dx into 1 by k. So this is ln 1 minus x. This is information is only x. Integrate. So we have to substitute the limits till 0 to certain x. So if you substitute the limits, you get L by V equal to minus 2 into ln 1 minus x by k minus x by k. From this information, what is L? L is nothing but minus V bar minus 2 ln 1 minus x by k. If substitute the values, you can finally get the conversion from the reactor is length equal to 3.545 meters. That means in this particular equation are supposed to multiply by k is also needed. Okay. So I hope you have got we have covered all the questions in CRE. Let us meet in the next lecture. Thank you.